Okay, so the first question is to describe Dalton's law and how it impacts oxygen availability at altitude, and to provide an example and illustrate it. Um, Dalton's law is the idea that the total pressure of a mixture of gases is equal to the sum of the partial pressure of each individual component gas. The effect of a decreased barometric pressure on partial pressure of gases can be determined by Dalton's law using a calculation that multiplies the percent of oxygen by the barometric pressure. And as we know, at altitude, barometric pressure decreases, which will overall decrease the partial pressure of gases. I can do an example. I have the formula written up here. This is the percent of oxygen, and this is the barometric pressure. So for an example at sea level, we know that the percent of oxygen is it's 20.9%, but it would be 0.209. And then we would multiply that by the barometric pressure at sea level, which is 760. And so then we would get the partial pressure at sea level is 159 milligrams of mercury. And so we would know that if the barometric pressure changes at altitude, so would the rest of the equation, which would end up with a lower partial pressure. So at higher altitudes, barometric pressure decreases, which would overall decrease the partial pressure of gases. For the second part of that question, it's asking to describe how humidification factors into oxygen availability and to provide an example. So when air is inhaled, it passes through the respiratory tract where it becomes humidified by water vapor. And this humidification process reduces the effectiveness of oxygen availability because water vapor contributes to the total partial pressure gas mixture, which displaces some of the oxygen's partial pressure. In this, Dalton's law still applies, meaning that the total pressure of gases in the lungs must include the partial pressure of water vapor, which at body temperature is 47 millimeters of mercury, and body temperature would be 37 degrees Celsius. So an example of this at sea level, we would use the same equation from Dalton's law. However, we have to incorporate the humidification in the lungs. So we would find the pressure total in the lungs by subtracting the barometric pressure, which is 760, by the pressure in the lungs, which is 47, which I talked about earlier, which would be 713 millimeters of mercury. And then we go back into the same equation where we multiply by the percent of oxygen, 0.209 or 0.21, and multiply it by this pressure, 713, and we would end up with 149.7 millimeters of mercury. And before we had 159, not including the humidification, and that is because this decreased the barometric pressure, which in turn decreased the overall partial pressure.